myself, introductions, and I was mentioning to Maya a bit earlier. I'd like to try and run a quick survey, and I've got a app that can help us do that, which will help us to get to know each other a bit. And then the first point I wanted to cover today was the data science 101. So as they call it, it's just wanted to bring everyone to the level playing field and make sure that we are all talking about the same data science, right? Because data science, as you know it, I think is a term that's been abused a lot, and it's been used more often these days to talk about all this artificial intelligence and machine learning and everything. But what does it really mean, right? So we'll talk about that first. And then we'll also talk about real world data science projects. So I'm actually going to talk about one of the projects we did for a client. And again, just to give you a feel for what do I mean when I say I'm working on a data science project, right? What are we trying to solve, and how did we go about doing that? What are the technologies? So hopefully you'll hear some terms that you can go back and start to study and research more on about, right? And then with the background of those two things, both the data science background and the projects, we'll then talk about a day in the life of a data scientist, which, again, when I get to it, I'll explain some of the nuances around it and all of that. Okay. Maya, my audio is clear, right? And you can see the slides, okay?
Yes. Okay. Thank you.
So first off, I want to do introductions, and I was thinking, I'm coming back to CUSAT to do a presentation, so I couldn't resist putting an old photo from our batch. So I think Maya will be able to spot herself out.
That's very nice. It's an old picture, yes. Nice picture. I don't have this one.
Right, okay, I'm not sure. The batchmates will probably, the rest of the group will probably pick you out, but hey, I'm going to start off with the introductions. So myself, my name is Siraj Ali Muhammad. I actually did my IT from CUSAT, Maya's batch, back in 2001. Finished off BTech and then went on to work for a firm in Cochin for a bit. It's called U4IT, but here and there, we went through that .com bust scenario, to be honest. We didn't have enough opportunities when we passed out. And then I chose to do my PG straight after. I did my postgraduate diploma in IT from IIIB in Bangalore, and that was probably the so we were called BI. So we were called BI analytics and consultants, but we'll talk about a day in the life of type scenario. Support consultant to try and figuring out data solutions, to doing infrastructure management, playing on network cables and all of that. And even when I finished off with Thorogood, I was kind of on the management team running the UK business eventually. That took me to Slalom. Slalom's a global consultancy. They've been around for about 16, 17 years now, and headquartered in the US, Seattle. And they were opening up their first global office, so to say, in London. And they wanted someone to lead up the BI analytics. And I took that challenge on. And in 5 years, we grew to about 20, 25 people. And the practice was a sort of, what they call a break even, right? So we were able to generate our own income and keep paying the bills and all of that. Very interesting period because, again, tie-up with the US was great, and we got to work on a lot of engagements with big names in the industry, the likes of Coca-Cola, Apple, Nike. It was just fantastic in terms of working for those projects. And more recently, so in October 2019, I picked up this role with Experian. Experian's a more homegrown name, The company's been around for about 15 years again, but headquartered in Trivandrum. And it was formed by people from IBS and Nest coming together and kind of forming something that they wanted to make a change in the whole software development area. A couple of years ago, the management had made a decision to go around into horizontals and specialize in certain areas, and I came on board to set up the first horizontal practice, as we say it, called data and analytics. And currently, I'm based in London, but I actually do a bit of both, right? So I, pre-COVID, used to travel out quite a lot. We have clients in US, Australia, New Zealand, Middle East. So I take care of data analytics for the company globally, but I'm based out of London most of the time. But I do travel back and forth. So again, come to Kerala very often. Family, I've got 2 kids, wife Rajita, she is actually working in Kerala at the moment, and kids are going to a school in Tripura. So again, because of my travel up and down, I end up coming to Kerala, Kochi, and being there at least half the time of the year, right? Right now we're in the UK. Okay, so it's time for me to hear from you. So here's what I want you to do. I'm going to ask you to take out your smartphones and scan the QR code that's on the left, right? Oh, hang on, I didn't want to do that. So hopefully you can see the QR code. Can you see that? If you can't get the QR code to scan, go on your browser. If you go to vvox.app and key in this ID, that will bring you into this survey as well. Okay, I'm going to open up a poll just to see whether you're all able to get in. The first one's just asking about locations, right? So I just wanted, this is a practice question for us. There's only four for us to go. So let me know if you're able to join in. I can see one of you have come in. Hey, there you go. There's a couple of you. That's really good. I was saying to Maya, I haven't run one of these for client sessions. I've always wanted to use it. I've used it when you're in the room and you can see all the 50, 100 people around you and kind of go, hey, just scan your code and get in. But I haven't done it on an online session. So this is good to see. Okay, I've got 6 of you. I'm assuming, I know there's about 18, 20 participants. So we'll try and get to something like 15 and then we'll move on to the next question. And here you go. I can see more. So lots of people from Ernakulam, as you would expect, CUSAT and all of that. I hope you're all staying safe. Shur and Trivandrum, Kozhikode. Oh, there's a couple of out of Kerala too. That's good. There you go. Ernakulam's just trumping up. Yeah, I've got 12 so far. 3 more, and then I'll move on to the next question. Okay. Just, I think you just touch in when you see the answers. You just key in and say yes to it. Yeah. Okay, 2 more. Final 2 more. I think that's what we're going to get. So let's say I'm going to move on to the next one. So, there's one more that came in. Oh, 15. That's good. Okay, majority from Ernakulam. That's what I thought. Right, and then Trivandrum and Thrissur. Okay, good. Good to have you all here. And then I'm going to close this poll and move on to the next question. So I just want to know, what's your primary reason for attending today? I should have also added Maya pushed me to join in, right? Listen and learn. My knowledge. Share opinions, ask questions, or anything else. That's brilliant. I think we'll all. I don't want to be judgmental, but I think you'll like the session today because we're going to cover a lot of interesting topics that you can cover.
This is an interesting survey, Siraj. Very nice.
That's brilliant. Yeah. Very good. Very good. And I'm getting more participation as well, which is fantastic. 15 out of 18. Okay, cool. We'll move on to the next question. So most of you are wanting to listen and learn. What are the top outcomes you wanna? Do you have any outcomes from today? So are you looking to develop new skills, to broaden your horizons, to increase your confidence, to learn and discuss new ideas, to meet new people? Maybe, I'm not sure, because if you're all in the same batch, then I don't know. To have a good time, that's definitely something you can do. And again, I believe you can select as many as you want, right? So click away. Yeah, that's brilliant. I think the free version on this one, I'm using the free version, which is why I have got to give a set number of questions and answers. There's a paid version, I believe, which might come in for colleges too, and you can actually get them to answer live. So you get to see.
Yeah, this is nice. Yeah, for classes. And they're sleeping away exactly. Yes. Yeah. Wake up time. Yes.
Cool. Okay. And final question. That's good. 15. Most of you are looking for developing skills and broadening horizons. And then the final one. What's your current knowledge of data science or analytics? Again, you're not getting graded on this, so you can actually happily answer. Okay. Counting down from 5, 4, 3, 2, 1. Great, thank you. I think that gives me a good picture of where we are. So back to my presentation. First things off, I just wanted to start off with a data science 101, right? So this part of the section, I'm just trying to pull a good understanding broadly about what is data science and what do we mean when we say data science, right? So we'll talk about that. We've just completed the introductions. Here's a map, right? This is a very old map of London. It's probably one of the early stages of people trying to analyze what story the data was telling them. Right? This one's interesting. It was from John Snow back in 1854, when London was going through a very deadly cholera problem. Right, so there was a lot of cases of cholera. And John Snow, what he did was he actually, I don't know if you can see, but he went through and made up all these bar charts on the roads, trying to say, where do you see most of these cholera cases? And so he mapped up all these bar charts on the street as they held through. So which side of the street you were lived on, and then you had those charts. And then that allowed him to track it down to say, actually, the problem, cholera obviously spreads through contaminated water. The problem that was happening was because of this water pump that was right in the middle, right next to where a lot of these people were getting their water from the same pump. And that was, there was a broken sewage next to it, and that's how it was spreading. Is this data science? Right? John Snow has actually used visual representation of data to try and understand what is happening with the case of, with the spread of the epidemic at the time, which was cholera. Right? Here's another one, right? So you've got the Google Maps. Very often when we were back in campus, we would have gone I've just drawn up a map from CUSAT to Kavita Theatre, right? So back in the days, we would have done these very often. Every new movie comes up here and there. We knew roughly we were going to take about 30, 45 minutes probably to get there. But today, I'm sure each of you are kind of, just start picking up your cell phone when you're able to go to theaters and things. You would have looked up that and said, hey, I've got 3 options. I can go via Padivattam or through the main, through Edapalli and things like that. And you know how much it was going to take for each of those. And you're able to do it. Google's using its A-star algorithm and it's trying to kind of work out what is the best way for you to go from point A to point B. And it's going through that shortest route, but also factors in for the traffic and everything. Again, crunching through a large amount of data. Is that data science? Here's another example. I don't know if all of you use Spotify. I use Spotify quite a lot. every Monday you get what's called this Discover Weekly. If you haven't used it before, please do. It's an amazing, again, I think you can use Spotify for free too. You just have to keep up with the ads. But again, if you haven't used Discover Weekly, do use it. I love music. But then what I tend to do is actually listen to the same albums or covers or singles for repeatedly over and over again. What Discover Weekly does is it has Spotify's algorithm that kind of looks through music that sounds very similar, or it's got about three things. It's kind of it's collaborative. So what you have, it analyzes on what users' behaviors are, and then it looks through content. So it looks through descriptions, easier when it's in languages that Spotify can understand, and it's spreading out these days. So if you're listening to sad songs or upbeat songs in English, then it kind of know what those lyrics are and the description says, and it's able to work out what's another song that could be similar. And then finally, it kind of breaks down the music to say, well, are you listening to more orchestral type or hip hop or jazz, and is able to categorize all of that and then make recommendations back to you to say, here's some other music that you might like. And it's totally new. So I'm surprised at how Spotify kind of nails these down very well, because occasionally I kind of get these blast from the past type, I haven't heard this for the last 15 years type songs, which Spotify is saying, hey, you might like this. Obviously, it doesn't know that I've listened to it because it used to be in tape recorders and cassettes back in the days. But now it's kind of trying to work out that based on my current likes and dislikes, this music might also fall into the same category of things that I like. Again, is that data science? You're number crunching, right? And finally, I wanted to bring up some boring dashboards, right? So this is what us in the business look at most of the time. Yes, it's an insurance broker portfolio, kind of saying insurance brokers are people who stand as a middleman between someone who wants to buy the insurance and someone who's actually willing to take on that risk and provide, at a premium. I work a lot with the likes of Lloyd's Insurance, who actually does specialist insurances in London. And they actually, for example, things like, insuring a cricket stadium or insuring a country or a satellite or Santa's beard or Beckham's leg, those kind of things, which you can't really put a value to. But again, these are specialist insurers who actually will say, right, we value that at X million, and then you'd pass on the risk for it. For similar brokers like that, these dashboards that we have on screen, what it helps them is actually to try and say, where do you perform in comparison to the rest of the brokers? It's bar charts, but most of the time, it's actually trying to tell you a story about how, in this instance, Zemlek or Kremlek was doing better than the rest of them. Are they selling more policies or not in the last 2 years or 5 years or 10 years? Or how does their performance look like? Or what's the brokerage that you're getting from them, etc. Again, is this data science? So the point I'm trying to make is, and I'm hoping it's much more clear for you, data science is just all about answering questions, storytelling with data, right? It is not, what it isn't, maybe we should have added that slide too. Don't get yourself really boxed into this idea that unless I'm writing an algorithm or a Python piece of code or doing something in R, this is not data science. Data science has existed for a long time. Yes, it's a concept that kind of brings all the statistics or the data analysis and all that related methods around informatics together. But the key thing is it's actually trying to put all of that together to make sure that you understand and are able to extract critical information from the data that it's actually provided to you. And you might use a varying number of methods to do this. Max is a common one. So you definitely look at kind of ratios, growths, year-on-year movements, and all of that. But then you also do statistics like mean, mode, median, and things like what is the average over a certain period of time, and into more advanced areas where you're trying to analyze the data in more deeper, right? So put simply, data science is just a combination of all these different things, and you're trying to answer questions or storytell with data. right? This is what Jon Snow was doing. Google was trying to answer a question about your maps. Spotify was trying to give you more options, or, again, your question on what new music exists with data, and everything that we looked at, right? I mentioned data science has been around for a long time. Yes, it has. This slide I don't intend to go through in a lot of detail. For about 70 years, right? So the term artificial intelligence was coined back in 1956. So imagine, so we're talking about 70 years ago, it was already there. And people are already talking about the Turing test, to identify machines from, all of those things. You'll learn a lot about these. Chatbots existed in 1964. Eliza, right, the first chatbot. So it's gone through these ups and downs. The chart actually interestingly shows those AI winter 1 and 2, which is interesting because that's when the interest seems to have dipped. If you're not looking at it already, I don't have it on my session today, but there's something called the Gartner hype cycle. Again, it's a very interesting one. There's a curve that it follows through for a certain period, but talks about how when there's a lot of noise in the market about a certain thing, everyone hypes up and there's an increased interest. And then you get to this trough of disillusionment where you kind of go, oh yeah, we thought it's going to do X, and then no, it didn't do that. So in here, you'll actually see it is doing this sort of same hike. So it's kind of going into the peak and then thinking, oh, no, it doesn't work. The chatbots are not ready yet. And it went through these couple of cycles. Do you know why? Primarily, it's just been because of the fact that you didn't have enough computational power or anything to be able to deal with the level of data that we were talking about. So over time, this new lease of life that we're seeing is actually being because of you're getting more data coming through. Data has actually been captured from various things. I was just yesterday, we were talking about how, these cookies that's sitting in our laptops actually collecting everything about us and sending through ads that are very specific to what we want to see and what we are interested in. So data has just been collected everywhere. Your watch, your thermostats at home, your cars, your refrigerators, all of these things is actually now talking to the internet, right? So at home, we have something like 20, 25 connected devices, irrespective of, even if you didn't do anything actively, right? So there's a lot of data. There's a lot of processing power that's coming up. And together, we're actually able to bring more reasonable outcomes at a much more cheaper price. So if you look at things like AWS or Microsoft or Google these days, you can actually set up your own environment and have it running and do it on a trial version, play around with fairly large volumes of data, and no one's gonna ask you to pay anything. You can just do it. So imagine that. Back in the days, in our days when we were doing our engineering, we'd have to go to a computer, what do you call them, a cafe, or I didn't have a computer at my own home when we did the computer science, when I did my computer science in my schools, or just about in engineering degrees. So again, from there, we are now gone to a point where there are 4 or 5 different computing devices at home. So price has gone down and volumes has gone up. That's the price elasticity that you're actually seeing in respect to data and computing. So that's only just triggered off. I wanted to kind of show this continuum here, because often people think data science is all about, oh, you're trying to predict the future, right? So you're going to say something that we all don't have any idea about, and this is just going to be the next big thing, right? But if you look at analytics, it actually follows through a continuum over many different types. So the first one's actually hindsight. So this is looking at what happened, right? The second one is more in terms of why is this happening? So that is traditionally what your BI tended to do, right? It's always looking at, okay, let me show you your history of performance in the last 6 months in comparison to the last 2 years. That's a traditional report that you would have written over many years, right? And these are all data science, by the way, right? Because you're still, remember my definition, you're still trying to say, how was your performance, or you're still trying to evaluate your performance. Evaluate your performance against a a certain period and trying to bring out a data story from it, right? Now, BI was heavily hindsight based. You're looking behind and saying what happened and why did it happen. The insight is actually starting from that, why is this happening, to kind of predicting what will happen, right? So your trend is down. For example, if your business trend was down, you're not doing enough sales and your costs are going up, you pretty much can figure that out from the first 2 to 3 months that's happening, because your curve will start to go down and then that trend will dip. And so you might be able to kind of say your margin's going down generally. So if you look at margin as a general business term, that's just a factor of two things, right? So you kind of say what's your income or your revenue, and then what's your cost. So if your cost is always lesser than your revenue, or your revenue is trumping up cost, then your margin is fairly good. If your revenue is going down and cost is going up, obviously your margin is not going to do great. And that such trends over time, you can actually pick up from simple BI charts or dashboards of metrics that actually people follow. And there are various types of dashboards. I mean, we won't get to cover all of that today, but I want you to, I'd really like, I mean, if you're interested, definitely go and read up more about KPIs and dashboards. And if you just do a Google search, you'll actually find a lot more examples that hopefully should be interesting and you can predict. And this final piece, the final piece on the foresight side, is what prediction is all about and prescriptiveness is all about. That's where all the AI and ML is trying to get to today. And there's various ways of this chart. As you go from left to right, the complexity increases. As you go up the chart, your business value is increasing. So obviously, if you can predict the future and say what's happening in next 5 months or 6 months time, then you're able to get through a lot of, make sure that the business is adjusted for that, and you're able to hit a certain level of margins and growth. So everyone's trying to predict. But there's two things that you should take out from this chart. One, data science is not all about just the prediction element. Data science includes all of these different types of analytics. But two, prediction, or that's where everyone's trying to put their mind at. And why? Because every industry is trying to predict in its own way. Manufacturing industry, for example, if you took that, they're always trying to figure out what product should I manufacture, and how can I optimize this further? So I know people, for example, I used to work with Coca-Cola for a bit. And what's very fascinating is they actually have these sensors set up on these different factory machinery that pumps up all this information about, am I working well? Or what's my temperature and all of that. Would you believe that many of these things actually reuse their equipment? So to give an example of soft drinks, if you had a factory that was producing Fanta, Coke, Sprite, and just soda, they actually use the same machinery in some cases to produce more than 2 or 3 drinks. And so if you have something that was producing Fanta for a bit, if you wanted to switch out to Coca-Cola, you needed the ability to clean it up and refresh and then come into the next product very quickly. So it's all about, people like Coke, for example, trying to predict what's my expected sales on Coke going to be versus Fanta in the next 3 months, so I know how much I need to produce, right? They'll be looking at further optimization, and then obviously around profiteering. Another industry that's big on this one is actually agricultural industry, right? Both from an environmental reason, but also trying to figure out, because we have a lot of mouths to feed. And again, how do we make sure that there's food enough for everyone? And how do we make sure that we're doing it in the most optimum way? There are various devices and sensors these days. I think, again, there's a documentary available about a farm in Sweden that's actually trying to do a lot more of this glass house types and kind of growing all the vegetables that you need just by the use of IoT devices. We've worked with a customer in the US for whom we've actually helped them understand what is the level of irrigation required at any point in time so that their plants don't die down. And again, you compare that against past performance to say, did you have a good harvest when you did that? And then you can actually tune it up and down. So again, the optimum growing factors, you're able to control that. And then the whole thing around logistics. Do I make something in UK and ship it out to the rest of Europe? Or do I make a glass house or have some sort of a facility somewhere in Europe so that I can produce it locally and then send it out shorter? Again, trying to work out various logistics set of things. From a healthcare perspective, they're trying to work out predictions around diseases and how, for example, if someone's showing up a few symptoms based on what they have done before, how does their future, what are the future illnesses that they could be at risk of, and how can you make sure that they don't hit that, right? There are various services like 23andMe or Thriva in the UK who kind of look at your genetics even and try to predict about what are you likely to be susceptible to, and hence what lifestyle change should you bring about today so that your life is much better over time, right? And think about those medical interventions. And of course, we are all trying to predict this thing right now. As I spoke to Maya at the start of the session, COVID cases in the UK has been much more kind of contained. This is a dashboard that's used in the US and Oregon. But there are various versions. I mean, from a screen print perspective, it didn't work for Kerala, but again, Government of Kerala has also got something very similar that helps us understand where are we in terms of the test positivity rates, and are we going up or down, and how does that compare, etc. And again, we have predictions in terms of when do we think this is all gonna end. All of this is driving that demand for data science. So this chart is something that I picked up yesterday from a website called itjobswatch.co.uk. A lot of people actually go there to try and find the next big jobs. And in the UK, there's a good trend about permanent and contract. So the permanent one is the orange line, permanent roles. So these are like, fixed roles, and you kind of can stay forever if need be. The contract one is where you're on a fixed contract for 3 months to 6 months, or could be even shorter or longer too. But as you can see, if I take the trend for data science, and if I look at that over the period from 2013, so it lasts about 8 years, 2013 to 2021, this is fresh as of yesterday, the increase has only been significant. The only reason we saw the dip in 2020 or 2021 was because of companies saying, well, I'm not sure of whether I want to put in more money there, because it is currently the pandemic means, I don't know if I'm going to make the same amount of revenue or margins as I would expect. And so maybe I need to be a bit cautious. That's all. The interest overall has just continued to increase. And today, if I go into LinkedIn or any other job portal and kind of type in data science, the number of roles that come up is just phenomenal, right? And have you ever thought why? This is the reason why, right? So this is a chart from someone called Matt Tuck. Matt lives in the US, and he kind of goes through every year. He kind of looks at all the different technologies. It's purposefully left very small. But if you want to go out and explore it, look for Matt Tuck. I'm sure I can share these slides through Maya at some point. So, and again, just look for Matt Tuck. You'll see he's actually gone through the pains of kind of calling out the different types of players in the market around each of these areas. So infrastructure-wise, AI and machine intelligence-wise, applications that are in the market, applications that are available in the industry, anything that's open source. These are all free, right? Stuff that you can available. And data sources that you can actually go away and kind of pull data from and do your own analysis. Things like marketplaces, financial data, airspace. So we'll talk a bit about this during some of the projects that I mentioned. And you can just go into data.gov.uk, for example, in the UK, and I can just pick up any data. If I'm looking for schools, I'm actually going to open source schools data, and I'm looking at, right, let me just look at performance over the last 5 years and see how they pan out in various regions. If I'm looking for a new place to move, I'm looking at crime data that's available. So data availability-wise is just phenomenally significant out there, but it's all very complex, right? And so then you think, so what's the excitement about, right? Because everyone's kind of saying, data scientist is actually the next big thing that you should be looking out for. I think back in 4 or 5 years ago, there was even a very controversial statement that came out in newspapers that said, data scientist is the sexiest job of the century types, right? It's all about money. I think people are kind of focusing, but just on this session, I want to draw a picture of reality for a bit and bring up this chart while we're on that topic. Again, same source, itjobswatch.co.uk. But if you look at the chart, the histogram, all right, so this is actually showing me a distribution of salaries for data scientists, again, in that last 6 months building up to as of yesterday, right? There is a significant, so obviously there's a peak in the middle, so there's a good chunk of people who get paid fairly well in comparison to a software developer that's fairly high. But then if you look at it, there's also people at the early stages, so somewhere between 18. So these are like, minimum graduate salaries in the UK, till about 45, 50K. And then some people on the far end too. So maybe the point I'm trying to make is when you say there's a lot of money involved, you're probably looking at these, very final area and kind of judging, okay, that's the next big thing that I want to look at, right? But the exciting part is, like I say, companies are looking to innovate rapidly. So this whole thing around everyone's trying to predict, yes, companies are interested in doing that. The whole thing around there's a complexity in terms of the data, tools, etc. And there's a lack of good talent kind of ties up, and that's the reason for the excitement. Now, positioning this whole thing back to you for a second, I just want to say, if you're on board, there are two areas that you really want to look at, right? Definitely the technical area, which is all around everything that you're studying in college these days, from analytics research, operations research, or statistics that you would go through. Machine learning, I'm sure you're learning big data, Hadoop, SAS or R or MATLAB, depending on what technologies you're picking up. These are all very important. I couldn't stress you any bigger. I know S4 means you would have probably finished up your math even, but all of these subjects that you learn back in college is significant. I mean, there's no day that I don't go through without having touched on data structures. Every single day of my last, if I take the last few months even, every single day I'm talking about it on some project or the other, right? So your technical skills are a absolute must-have, and you should make sure that you actually have the skills. But the key thing is the soft skills is also important. So I'm really, pleasantly surprised and very happy for you that you've actually made the time to come in and do these sessions like today. Whether you pick anything out of my data science session or not, this is actually helping you to build the softer skills around you, which is everything around listening, you're learning. A lot of you said you're here to learning new things. You want to communicate with people and then make sure that, you have a point of view. Very often when I go into projects and I'm saying, hey, I found that you have a problem with your one plant that's actually causing a significant productivity decrease across your entire machinery. And you have to be able to persuade your listener to understand what you're talking about and bring them on board with you. Right. So all of these soft skills, problem solving, oh my God. I mean, the number of times that you're given a brand new challenge and kind of looking at it and going, right, how do I convert this into a set of mathematical equations or programming stuff that I can actually write up and then bring it all together and make it in such a way so that it's easier for the business user to understand. And business users often, they're only about thinking about money or performance, and that's what their numbers are on. If I want to give them something that they can fairly easily digest, then I need to shape this up. And so thinking through and defining all of that is just critical. And at the end, I'd also say time management, because everything around team building is important, but unless you're able to manage your own time, you will just see that, well, you just shoot through what was given to you or made available to you, and you end up not being able to complete. So those are the skills. And again, like I said, this is by no means, this is a 2016 survey. This is by no means the end goal of what you are looking to achieve. It's just a kind of pointer. Look for these things. And as I'm sure, by the time we finish the session, there are more things that's coming up. 2-3 years time, by the time when you're going into companies to work, these would have changed even further. But keep this in mind. Don't just focus on one area. Your technical needs to be strong, but your soft skills needs to be strong as well, right? So that's the data science 101. So hopefully that gave you a bit of a feel for what do I mean when I talk about data science, the fact that it's not just the predictive algorithms that we're talking about, but it's also the BI and the John Snow type data visualizations. These are all data science, right? Now I want to talk a bit, like the next 5 minutes or so, a bit about the real world projects. And I'll talk a bit about an employee retention program that we were helping a specialist call center with. It's fairly recent. We've actually just in the final stages of presenting the work back to the customers and kind of selling it internally. Employee churn is actually a very common problem for call centers. So if you think of it, same thing, right? So people ring you up and you're trying to give them an answer solution on the phone or on chat or on forums, etc. That's a call center, right? But what I mean by a specialist call center is, in this particular case, my client is a clinical specialist, right? So they're actually people who understand medicine and background and things. So they have a bunch of doctors or medical professionals calling them for advice, and they would go through a standard set of SOP type documents, to standard operating procedure type documents, and give them advice based on what these call center people might have access to. There's another set of people who actually are something like, suicide helplines and things like that. If you're feeling really down, you're not mentally there, you might want to call and speak to someone. And again, there are people who are trained and skilled in being able to understand, try to understand you and give you that listening ear and make sure that, you get the help that you need. Again, these are specialist roles that you can't just, you can't put any graduate out to that role before. You have to go through a serious level of training. And that training is what makes this whole employee retention really important. What we find is replacing employees in such specialist call centers is actually quite expensive. Costs about $5,000 to $7,500. Right. These charts are real data from the client that we were looking at, right? So year on year, their headcount growth was kind of on 23%. So if I had 100 people today, I'm actually becoming 123 people in the next year. That type of headcount growth, right? So the only year that they didn't have any growth was the time when they went through that COVID challenges, right? But otherwise, they are having a good growth overall. But they also have about 44% people leaving, right? So these are people who are kind of, for whatever reason, kind of choosing to say, no, this job is not for me, I'm going to leave. If you then talk about all that people who've left in the last 5 years, you're talking about $1.7 million that the company would have paid just in terms of staff replacement. And what we're trying to say is, even a small project like a 25K, a project with a few, for a few weeks, we'd be able to build something that will enable them to go back and understand why people are leaving and how they can cover that, right? How they can ensure that they don't leave. The way we went about that solution was actually to sit down with the business and understand what their employee relations are, and basically digest all the historical data about HR, right? How many people do you have in the company? What degrees do they come from? What ethnicity do they have? What's the gender? All of that details around the people, and then try to work out, who do they report to? Who else is there in the family? And what's their work experience? The feedback that they get from their clients, the type of calls that they're making, and the feedback on the calls. And we get all of this information to then formulate a high-level solution framework to say, okay, this is the type of analytics we're going to use. And from there, we actually went on to design something, and I'll talk about the analytics engine briefly, that just churns these numbers using the mathematical models that we have built. At the end of all of that, we then build the dashboards, which take all these definitions of data, and then we are able to derive the insights that we require. The solution itself was quite simple. So all of the bits on the left existed. So they had their turnover history, they had employee details, and the call data too. which was pushed into a churn database. So we call it a churn database. We pushed that data into a database, and from there used Python and Power BI. I don't know if you're familiar with the tool. It's a tool from Microsoft. If you're not familiar or haven't heard of it, please do go check it out. It's growing in demand very much these days. And I'm sure if you bring it up on your CV, talk to your prospective employer, they will definitely be interested in you. So definitely download Power BI and see how that integrates with the rest of it. But using it, we were able to number crunch and produce some insights. And again, the machine learning models that we created were sitting in Python, and Power BI was just invoking it and pushing it back into the database for us to then consume it in dashboards. I mentioned that analytics engine we built. We broadly followed the CRISP TM data mining methodology. If you haven't come across it, it's again another subject for us to go through in a lot of detail, but I'd encourage you to go and read. But what we're doing there is explained in a few steps. So broadly, CRISP talks about how you should understand the business requirement and then look at the data and then transform the data the way you want it before you go and build. But that build, the analytics modeling side, is what I have tried to explode in the chart below. What we were trying to do is we were trying to say, okay, let's get all the available data that was existing out there, and then we'll process it, make sure that it's in the form that we want. From out of that, we'll actually say, okay, these columns are quite important for us. Telephone number, maybe not, right? And so we'll take that out. But birth date, age, ethnic background, those kind of things we might keep. Gender, degree that they have attained, how long they've been working, year of experience, etc. That we might keep. And then based on all of that, we use various models, like either using AutoML or time series analysis to try and figure out, okay, based on what we know about the employee, how likely are they to leave? So that model will run it, test it against a new set of data that we get, and based on all of that, we are able to give out some outcomes. From a project perspective, what it allowed the client was to kind of go back and say, okay, we can identify employee churn risk much ahead of time. So about 6 months to 3 to 6 months ahead of time, they were able to say, oh, okay, yeah, I've got this employee here. Let's say Siraj, he's very unhappy with what he's doing right now, so he's likely to leave. And so HR was able to intervene and introduce new schemes and have a conversation with that employee to say, well, why is it that you're not finding your place here? And what do we need to do to make it better for you? And have some of these conversations so that they can actually prevent that person from leaving and thus contain the financial impact. What we are hoping to achieve out of this, and this is not an outcome that we've received yet, but we will see this in the next few months, is that hopefully the number of resignations, that number that I showed you right at the start in terms of 44% churn rate, we're hoping that that'll go down. And as a result, we have much happier employees, better job satisfaction, and obviously productivity, right? So that's an example of a real world project that we've done before. And finally, last few slides, I just want to talk about the topic that we came in for, right? A day in the life of a data scientist. A big thing for us so as I was writing this up, I was thought, it's different for different people. I call myself a data scientist, but again, what I do will be significantly different from what a data scientist at Spotify does, for example, or a data scientist at the Highways England kind of, managing the traffic side of things are doing. So everyone does a different thing. And even in my own scenario, the various roles I've played between Thorogood to Slalom to Experian now, they are different too, because it kind of varies from one place to another, depending on what the company's objectives are, right? And then even within Experian, I was kind of looking at it and going, well, my week from one week to another is different, right? Because of the types of projects I'm working with and all of that. So days are different, we work on different things, but this particular set of slides that I've put together is actually just my last week, for example, right? And if I look at my last week and say, okay, these are the type of things that I'm working on a day-to-day basis. And there's 3, right? The first one is actually just pure teamwork and communications. You'd be surprised at the amount of time that I spent on various things like, having daily briefings with the project teams, making sure that they are able to understand, we all have a good picture of, where we are on a particular day, and we kind of discuss about what any challenges, if anything, or any blockers that are there, and if people need any kind of support as they go into the next day's job, or whatever they're working on a particular day. COVID's made it interesting. We don't have to be global for project teams to be spread out in different locations. Just like we saw, we have people from everywhere, from Trivandrum to Thrissur or Ernakulam, or even outside Kerala, on this call, right? And if I take project teams, I have customers who I work with in Australia or in US, and these are big global project teams. So last week we had something that we went live with people in California, in Texas, and folks spread around in India because of the COVID challenge. And we were all on a call for quite some time, just trying to get things into production and ready for the client. So it's a common thing. But the big thing is, data science is not the business in all of these scenarios, right? It's just one part of it. So very often we are actually finding that we are speaking to the marketing people, or people who are actually involved with the sales side of things, or the production elements, to try and say, what are you trying to do? Just yesterday, we had an hour and a half session with the chief financial officer of a fintech company, again, trying to understand how is he doing his analysis, because we bring the tech expertise into the call, but the business or the financial expertise sits with the client, right? So we're trying to bring the two together to make sure that we have a good outcome. And then I must admit, sales is, we do a lot of sales, but the moment you say sales, oh, you're a sales guy, oh, I don't want to talk to you, thank you, call me back later, right? That's what we normally say to people. It's not a dirty word though, right? It's all about just trying to understand what is it that your businesses or your clients want, and you're able to serve them with data science or whatever in terms of work. And that can change from one case to another. And I love it because it brings new opportunities to you at all times. So that's the teamwork and comms. The big thing that gets me excited is the data analytics piece. And a big caveat here, if I had all these 4 or 5 projects come in at the same time, I'd have a very happy day. But it doesn't always work the same way. So the first project here that I was talking about is, I had an hour session, almost every day last week, working with the technical architects and the user experience guys to kind of work out. We've done a first phase for a fintech and financial advisor solution, and we're kind of going back and saying, well, how will you model the data for, this is working on stock market data in the US, right? How will you model and predict how the growth is going to be for a certain portfolio in the stock market over the next few years, right? So we're working on interesting projects around it. Another one that we're working, again, just gone live, that I mentioned last week, is kind of reviewing the final solution. So this one's a construction engineering company. They build these metal sheets and pipes that goes into various buildings and the likes. So we were kind of building an estimation tool. The tool came in from the software dev guys, but we were kind of allowing them to do comparison between different projects and do a good analysis that way. I know I'm coming up to the hour, just 2 more slides to go through and I'll be done. So we were reviewing the final solution. We were looking at strategies in terms of, for a furniture retailer, we're trying to figure out what products should they stock and what should be dropped out in terms of optimizing their profits, right? And then, as usual, I'm kind of working with junior members in the team to try and help them with problem solving or providing guidance where they need that support. So this is the core part of it. If I get all of these 4 things, or 5, 6 different projects to work on a particular day, I'm a very happy man. Very often it happens that I get to do 1 or 2, and then the rest of it is all teamwork and comms or business management, which is everything where things like working with the sales and marketing people to develop our materials, that marketing content, or even exploring people like Data IQ. Or this week we were connected with the partners from another Microsoft partner, but to try and understand how they would have various data pipeline technologies that we can work with, or even looking at recruitment people to try and find good folks out in the market who we can bring onto our team in the next few months to a year. And then there's always, I'm not running this for charity. I have an accountability towards the senior management to say, hey, Siraj, so we started a year and a half ago, where it was just me. And today I've got about 30 people in my team, and we're trying to grow to about 50, 60 people by the end of the year. And so growing that and making sure that the margins and revenue that's coming out, the business is flowing, I have that accountability too. So I end up spending a lot of time with all of that. Right. So that's my set of slides, Maya. So I just wanted to open up the floor for any questions. I know we said we might not get any, but let's, I'm just going to see if we can switch over to the Chrome and see if there's any questions on, does it come on chat? Okay, yeah. If there's anything, feel free to ask.
Guys, you can put it in chat if you don't want to unmute your mics. You can ask. Any questions?
I hope that's landed okay, and I think I didn't. There's a lot of content out there, and happy to share the slides. So feel free to send it out to the wider group.
Yes. I'm sure all those who said that their knowledge was very low at the beginning would actually have understood at least what data science is all about. So thank you so much, Siraj, for that. That really at least clarified their thoughts is what I'm hoping. Any questions, guys? Okay, so there is a question there.
Yeah, I've got that. So if an undergrad wanted to do an internship in data science, what hard skills should he or she learn? So core ones that I would say is definitely Python or some programming language like that. Because I'm assuming by the time you finish your engineering degree, you are likely to come out with a good level of problem-solving challenges, right? So you kind of have done lots of verbal, non-verbal questions, and you understand it. But being able to translate that into a programming language is going to be quite key. So do Python, and again, if you haven't registered on Kaggle, do that. Kaggle is a good site for you to go out and get new data sets and take part in competitions and kind of pitch against other people. Often they give fairly good prizes too, $10,000 and so for every winner who actually makes it through those competitions. So Python for sure. And then I would look at anything that is around one of these free tools that you get in the market, like Power BI, Click or Tableau, or take one of these visualization tools. Definitely people here, students here in the UK do that, and they come into the businesses with a much better understanding of what's available out there. So do that. I know the second question from Gokul is also very similar. Thanks, Arjun, for the question. Gokul is also very similar in terms of essential tools that you should learn. Being able to understand, I'm sure you're all using Colabs and Jupyter Notebooks and all of that, but make sure that you have a good working knowledge around being able to say, I've got a data set. If I want to do my EDA around my exploratory data analysis around it, what do I do that with? How am I going to access the data set? Is that on R or Python I'm going to write up? Okay, if so, how does my notebook look? Does it have a structure on it? And these days, you don't need to get any more fancier than that. As long as you have those, everything around, the PySpark, the Apaches, the synapses that are out there, the snowflakes, all of those companies will invest in you, right? But what they won't invest is the fundamentals. That's what you will get rated on when you come into the interviews. They'll expect you to know that. And if you don't know that, they'll be kind of going, I'm not sure I want to take a chance on that candidate, right? So be strong on your fundamentals. That's something that you can do straight away. In fact, that was going to be my last parting slide too, because I want you, three things that if I want you to really take away from the session. One is that programming skills and the fundamentals on statistics and math. Definitely keep that on, and that's really important. Stay up to date on forums, because I find that this is a very fast-paced industry. I spend a lot of time online just reading up about what's out there. Towards Data Science is a good one. There are lots of podcasts that I listen to. And again, try doing that. It's really interesting. You just get to know a lot of people, and then maintain a healthy interest in businesses, because you should know even the big names, right? How does Apple make their money? How does Nike make their money, right? Or if I take Goldman Sachs, how do they make their money, right? And at the end of the day, your whatever model you're writing up or doing needs to support these businesses in doing whatever they're doing at a much better pace, right? So keep that in mind. So hopefully, Gokul, I've answered your question. Another one from Jitin: should we always go for a full deployment while doing for a data science project? It depends, really. There are many cases where I've actually stopped halfway through and given the story to the client. One thing with data science is actually you want to fail really quickly and as early as possible. So if you get to a point, don't end up spending time polishing it. If you can actually finish sooner, even if it doesn't go through a full deployment, that is really helpful. I think you saw my employee churn project, right? It's only 25K. And these are not, most of our projects are in the hundreds of thousands of dollars, but this is a very small one. And we're trying to say, we don't know whether we're going to get the outcome that we want when we start the project. So very often we don't have the opportunity to go through it completely. So not required, Jitin, is my answer. Abhishek, is it possible for a non-CS civil engineer grad to find jobs in data science domain, and is that advisable? Welcome to the club. I'd say absolutely, right? So my best hires ever, and I mean ever, in the last 20 years, my best hires have all been non-computer science people. So sorry to say that on this group. Chemical engineers, civil engineers, mechanical engineers. I just don't know what is it about these trades. But people who come, I suppose, if you're going to make a decision on you're going to move from one trade to another, you have to have that much more determination. Maybe it's that determination that makes a difference. But people who come in with that background, it's just been so amazingly fantastic. Not just my feedback, my clients come back and say, oh man, I have no idea how you managed to get that into that graduate who just came 1-2 years. They're just like on fire, right? It just happened so brilliantly. So absolutely, we're open to all. I would say data science is open to all.
Any more questions, guys?
Hello.
Hi, sir.
Hey, Suraj.
Sir, first of all, I just want to thank you for an amazing hour. It was very good and very informative.
You're welcome. You're welcome.
Thank you, sir, for so much for spending your time. So the question I want to ask was, you have been in this field for so long, so you know what we should do and what we should not do. So Can you give a brief about that?
Yeah. So what you should do, definitely learn the fundamentals, follow the programming and everything we talked about. What you should not do is get dejected, because this is actually a field that will throw you down so many times, right? So you'll hear all these fantastic stories of, oh, we were able to predict to the 95th percent of accuracy that, you're going to get so much churn in a particular set of subscriptions on a mobile connection, for example, or, these are the channels you should do, or this movie is going to do that very well because we know the ingredients are all there. But it is, at the end, you're actually predicting the future. No one can say. No businesses out there predicted COVID, for example, right? And everyone's numbers went down. Every single business went down, right? And so things like these will throw you down massively, and you should never get dejected. What you should also not do is actually skip through things without understanding at this age or this phase of your life where you are. This particular, I did a course recently from IIT Roorkee last year, and I went back to college only because I thought deep learning was a phase where I wasn't really cracking it, right? And I mentioned about my passion for music. I wanted to try and do this thing around breaking down the elements of music. We talked about how Spotify does it, but I want to listen to music and kind of say, I want my algorithms to listen to music and say, there are about 5 instruments in this. And in these 5 instruments, here's how the drums is going. Here's how the strings are going. Here's how the piano is going. And here's how the guitar is going. I wanted to break it down. And I wasn't able to do that myself, just going through various Udemy courses myself. So I ended up sitting down on the course and spending almost a year, about 9 months. We went through weekends that we spent about 3-4 hours. I would come in when everyone else was watching a movie back home. I'd be sitting, locking myself in the room and kind of going through these sessions. So break it down. You can get there. This is not really rocket science, but definitely break it down and don't get dejected. Just keep on at it. If you're one of those that who, at first you don't get it, and I have my son's probably like that. He just kind of goes, I tried for a bit, and then no, it doesn't work, and he throws it away. I wouldn't do that with data science. Keep doing on it, and you'll get to a point where we can't take you off it, right? You'll be like really onto it full time. So those are my two advices. Hopefully that helps. And Suraj, thanks for the kind words. Terence, I have a question from you. As an undergraduate student, should I focus on DSA or improving my skills in the domain I want to join data science? Don't focus on, I wouldn't focus on one particular area right now, especially as an undergraduate. Again, my own personal experience, having gone through the BTech degree and then doing the MTech, when we got into the post-graduation, all of us, in fact, we had about 130 people and 148 people in our batch when we got to post-graduation. And everyone, again, back to Abhishek's question, there were a handful of non-computer science background students too in the postgrad, right? We all came with different knowledge levels. We didn't do our specialization even till the end. The final semester was our specialization. But like I said, I went into databases and writing up. One of our projects was actually writing an entire DBMS using C, right? Which is just fun. We didn't do that till the final project. But even then, I don't think I had very narrowly focused on saying, oh, I want to go into BI and I want to go into retail side of the BI. That happened as I did my work, and it turned up. You'll get various different opportunities. So the problem with focusing up front is that your opportunity to shine in becomes very small very early on in your career. And you're not sure. I mean, today you might be sure, but two years down the lane, you might not be sure that that's what you want to do for the rest of your life. So if I were you, I'd say, keep it as generic as possible, suck up, be the sponge today, right? Suck up as much of things as possible. And over time, when you're doing this on a day-to-day basis, you will naturally come to your core area where you want to focus. So I'm just one among many, but if I look at my batchmates or, our batchmates, or even look around me to see who else is out there, there are people doing various types of work, right? And I was thinking, did he know that he wanted to do that when we were back in TD having our, bun and cutlet? He didn't, right? I mean, we didn't know that. Or at that time, it was just about what we were learning and what we wanted to, those exams that we were hitting every semester, or just the Arts Fest, maybe even, that was what's on our mind. And we didn't have that broader understanding. But over time, that will come to you. So right now, my advice is, keep it generic, learn as many things as possible. There's nothing like, that's going to go bad. If you get half an hour, definitely pick up something like Udemy. LinkedIn has a lot of courses. There's a lot of student offers around. So take that and definitely read up and watch more videos as much as possible. Plenty of free material, guys. So yeah, definitely do that. Don't narrow yourself down so early on. Yeah. Good questions. Thank you for keeping it interactive. Yeah.
Any more questions, guys?
Would you recommend getting placed in a company after BTech and then work for a few years and after that pursue data science? Absolutely. Getting a job, jump at it. Don't let it go. But again, depends on what type of job too, right? So keep your aspirations always really high. And when you say recommend getting placed in a company after BTech, there are some cases. So I've been hiring from campuses as well for quite some time now. Right? So some students who come to us say, or even experienced people. So just the other day, last week, I spoke to a couple of people from Infosys, and they were all hired in. And Infosys has this practice of training everyone on .NET up front. Because if you look at it, these are all generalists trying to do certain jobs. And so from their perspective, if I hire someone, I want them to be billable or revenue generating very early on. So you will get trained on these generic sessions first, and then you'll get into data science. So one thing I'd advise is if you have that appetite for data science now, then definitely find the right companies, at least to a 50%, and then the rest is on chance, right? So even I can't say what projects I'll have in 3 months' time. Some people join me and say, Siraj, I want to do the best project. And I'm only joining if you give me that. And I go, well, I know what I have now, but I don't know what's on for dinner 3 months from now. So I'll make every effort to do it, but I can't guarantee. So it's a tough question to answer, Jitin, but I think if you get the opportunity for the right job, just jump into it. And like I said, data science is not markedly, it's not that final one thing on this slide that we saw, right? It's everywhere. I do data science working with my recruitment team, trying to say what is the salary expectations of people who are coming in, and we help them understand which colleges or locations they should go to so that they can do things better. I'm doing data science, all on Excel, right? So again, you can do that. It doesn't have to be specific. Rithal, thank you for the comment. I wanted to know how beneficial a post-graduation degree not. I think very, and in fact, these days I've been thinking, had I known that upfront, I'd probably have gone into even a PhD at that phase, because data science, there are two types of roles in data science, and I should have probably used this in my session. One is where the types that I'm working on, which is more like, small services focused, and we're trying to help companies in, oh, have you heard about data science? We can help you with these things, employee churn, or trying to optimize your factories, or, all of these things that we're coming up as the one-off sessions. Another big part of data science is actually companies investing in data science themselves. That element, they will never come to a services company for, right? Because if Spotify knows how to curate the next best music, they're not letting anyone else know about that. They're going to guard that, like deeply. And so any company you take, product company you take, they will have their own in-house grown, PhDs who sleep and think data science and do only that. And if that is your passion, so my passion is actually a bit of, my challenge is I can't keep my focus on for 3-4 years at a go in a single project. I'll get bored. So this multiple projects keep me really exciting, and I can swap. Whereas if your mind is at, just doing one thing and you want to just go really deep into it, then that higher degrees, post-graduation, PhD, etc., will be helpful. So that's one thing that I think you should try out. And again, there's no harm in making the decision 2-3 years down your career, right? So you jump in to the first job that you get at, and then you realize, because unless you try it, you won't know, right? So try it out, make that call. But I have seen, my experience has been that there is a lot of data science people out there with a post-graduation or even higher degrees, PhDs and the like, more than one PhDs, right? So definitely worth going. Yeah, very good question, and it's something that I missed on my session today. Thanks, Rithik.
Hello. Hello.
Okay,
Hi, Siraj. First of all, such a great session, and I guess everyone got to learn a lot.
Thank you.
My question would be, when you're going on to recruit people for data science, so what are the key skills you look in? What are the most important skills a person should have? Yeah.
So we want to see that you're interested in data overall. And so any questions, so we'll do our own, so our process kind of typically starts off with doing a case study, right? So we'll give you a data set and say, here's the problems that I'm expecting to see in that data set. Can you go find it out and then come back to me with a set of recommendations from yourself? So it'll give you access to the data. It'll likely be in the megabytes, touching gigabyte size. And we'll also tell you, till now we've been using a road traffic accident data that we have, and it has accidents data for the last 10 years. And we're telling you, go analyze that data set and tell me, are there hotspots or are there reasons as to why accidents are happening in certain areas more often than others? So, and we'll ask you about 8-9 questions on it. And one thing you want to see is your approach to it. So what answer you come back to me with is irrelevant, right? No two candidates have come back with the same answers. I'll give you this, right? Because they'll all come back with different answers. But the thing to remember is how you go about doing that, how you join your data sets, how you're then going to run, what data analysis are you running on it, and then eventually how did you get to the model that you were running on that data set to try and predict? How did you choose your test versus train data sets, and how did you analyze and finally visualize or even make that case back with me? And again, how persuasive were you on that session to say, Siraj, I think I found the next big thing, and this is what you need to do to try and prevent accidents. All of that is important. So there's no one key skill, but that's why I was saying, back on the skills slide that I shared earlier, that's from 2016. And I was looking at those content and I thought, it's interesting how unknowingly I'm looking at all of that's on there. I'm looking to see how well versed are you with your Python code, right? Did you just copy paste that code from somewhere else and just run it? And you can do that, right? And today you have access to forums. There's nothing stopping you from doing it. But as long as you understand what that code is doing, I have no problem, right? But I want you to understand what it's doing and be able to change and tweak things as you're on it. If you can't do that, then you're not giving me the same value back in for it, right? So it's everything. It's a bunch of everything, Utkarsh. I mean, there is no golden answer to it, but your approach in terms of how you tackle such queries and such challenges will be very relevant. And even if you came back to me and said, and this has happened, one candidate ran it for a week. So for experienced people as well, we do the same thing. We give them the case study and say, spend an hour or two over the next week and see, where you can get at. One candidate came back to me and genuinely said, I had to go live with my existing client, so I just couldn't get any time to work on it. But here's what I had done. And it was so genuine that whatever he had done was absolutely spot on, right? He only got maybe half an hour, 45 minutes on it, but the approach he had taken for that long was absolutely spot on. Today he works for me and he is, one of our star performers. He does that day in, day out. So I think someone else asked, do you have to, Jitin asked, right? Do you need to do full deployment? No, you just need to even show yourself, be yourself in that moment. And you'll only be able to do that once you have the right skills and expertise. So the more movies you watch, you probably, the lesser you get the opportunities now. But the more challenges you take up on Kaggle, you will see that you've done 10, 15, 20 of these. And, the next time it gets it, like my mom used to say, whenever I call you up from sleep, you should say this answer. And I used to tell my mom, this is such a repetitive thing, parent stuff to do. And I probably do that to my son these days or my daughter. But the thing is, it needs to get to that level of fluency that you understand this is what you're going to follow when you get a particular, this is my approach, right? And my approach has been distilled from the various things that I see in the market or I have seen people do, right? So hopefully that helps with that. I don't know.
Yeah, and thanks a lot for that.
Welcome.
Thank you so much, Siraj. That was such a patient, question answering session. You literally took each and every question and answered it to the best. I mean, I don't think they have any queries whatsoever left now after hearing you. And you made it so crystal clear. I'm sure the students are way better than they were when they were at the start of the session. I'm pretty sure that.
Glad to hear.
And you really, your whole presentation was very comprehensive. And even now, the question answer session, most of their queries, I'm sure, would be answered, and they will now, try and focus more, or maybe, increase their focus to go towards their path. So yeah, it's very good. Thank you so much. Thank you so much.
Absolutely. Yeah, so feel free to, LinkedIn is probably the best place. Emails I get a lot, but LinkedIn is probably the best place to connect up with me. I know I've had a few people connect in this week, which is great. And again, stay connected. We follow other people too, right, on LinkedIn, because it's a good professional network. I get a lot of insights coming from there, because depending on your network, you actually get a lot of good feeds coming back in. So definitely feel free to do that. And thank you, Maya. I think it was a good opportunity to connect back in. Anything for the alumni, right? So all good. Thank you so much.
Thank you so much, Siraj. We had fun having you. Thanks a lot. Thank you for your time.
Brilliant. Thank you.
Bye.
Thanks. Bye.
Thank you, students. Thank you for being there. Next week, we'll be having a basic course by Faizan, who's your senior. who'll be taking on OSDBMS, the importance of it. So hopefully that will help you with your placements so that you can concentrate on the core subjects, just like Siraj told today. So we'll be having that. We'll be floating the posters next week. So yeah, so stay tuned for next week too. So thank you.